Your testicle size reveals more about your personality, parenting potential, and evolutionary history than you ever imagined. And the science behind it is absolutely wild. Today we're breaking down the shocking biology of human testes and what yours might say about you. Unlike elephants whose testicles remain deep inside their body cavity, we primates carry ours externally. Compared to dolphins whose testicles comprise roughly 4% of total body weight, equivalent to human testicles weighing around 22 pounds, you might assume ours are insignificant. But understanding human testicular dimensions requires comparing ourselves not to dolphins, but to our fellow primates. Relative to body mass, human testicles are triple the size of gorilla testicles, yet one-fifth the size of chimpanzee testicles. This variation connects to two scientific concepts: pre-mating sexual selection and post-mating sexual selection. Pre-mating sexual selection involves badges of status, physical traits signaling social dominance and reproductive potential. These are characteristics that help male primates attract mates successfully. Examples include the enlarged noses of proboscis monkeys. Larger noses correlate with increased mating success. Other examples include the redder facial patches of geladas or the more pronounced cheek flanges of orangutans. Some research even suggests beard thickness in Homo sapiens functions as a pre-mating badge of status. Post-mating sexual selection concerns the reproductive competition occurring after mating, specifically the quality and quantity of sperm production happening within the testicles themselves. Male reproductive success depends on combining pre-mating success with post-mating success. Here's what's fascinating. Research consistently demonstrates the showier the badge of status, the smaller the testicles. The showier the badge of status, the smaller the testicles. It's an evolutionary trade-off. Large flanges mean small balls. Prominent noses mean small balls. Redder patches mean smaller testicles. Researchers studied howler monkeys and discovered males with the most developed larynxes, those capable of broadcasting the loudest low-frequency vocalizations, possessed the smallest testicles. Even research on human males found correlations with voice pitch. Men with lower, more attractive-sounding voices tended to demonstrate lower sperm counts. So what's happening here? It's evolutionary trade-offs between pre-mating and post-mating sexual selection. The metabolic energy required to maintain physical badges of status versus the energy required to maintain testicular mass. Research establishes that larger testicles produce more sperm. This relationship holds true in human males as well. Men with larger testicles generally produce greater sperm quantities because larger testicles contain more seminiferous tubules, the sperm-producing tissue. In the animal kingdom, males investing increased energy into badges of status gain greater access to females, thereby decreasing their need to invest in testicular size because sperm competition between males diminishes. The prominent nose attracts mates successfully, eliminating the need for larger testicles producing additional sperm. Therefore, increased male investment into badges of status decreases sperm competition, which relaxes selection pressure on sperm production, ultimately reducing testicular size. Perhaps men capable of growing thicker beards possess smaller testicles. However, one survey found men with larger testicles invested less time in childcare and family care compared to men with smaller testicles. Smaller testicles correlate with better fathers. Small balls might equal better dads. The evolutionary trade-off extends to parenting behavior. This finding links to other primate studies. Gorillas and colobus monkeys possess smaller testicles because they mate exclusively, whereas primates having intercourse with numerous partners, like macaques, possess larger testicles due to sperm competition. Perhaps men with larger testicles make less committed partners because they're less inclined toward monogamy. It's an extrapolation requiring more research, but the pattern exists across primate species. What about asymmetry? What if one hangs noticeably lower than the other? Human scrotal descent links to the fact that sperm production optimizes at cooler temperatures. That's why scrotal skin is remarkably thin, and why the blood supply creates a cooling exchange mechanism. Scrotal temperature measures 2.5 to 3 degrees Celsius lower than core body temperature, optimal for sperm creation. Cold external temperatures cause the scrotum to contract and pull closer to the body. Muscles called cremaster muscles retract when cold and relax when warm, regulating temperature continuously. Each testicle moves independently, maximizing available surface area for cooling. This creates considerable asymmetry as testicles cool themselves independently. Additionally, the scrotal sac tightens upon arousal, helping sperm warm up before ejaculation. But this positioning offers another evolutionary advantage. Keeping testicles closer to the body during vigorous intercourse prevents damage. Think of your scrotum like a smart thermostat, constantly adjusting to maintain optimal conditions. Regarding scrotal droopiness, this varies considerably between men. Just as people possess different-sized hands, people possess different-length spermatic cords or varying scrotal tissue. One certainty exists. Everyone ages and skin loses elasticity throughout the body. Therefore, yes, as you age, your testicles will become droopier. If you've noticed one testicle appears larger than the other, that's completely normal. For most men, the right testicle measures slightly larger than the left, whereas the left testicle more commonly hangs lower. This connects to individual anatomical variation. As primates, our testicular shape, size, and positioning represent fascinating components of our evolutionary history. Our testicles are living proof of evolutionary pressures shaping reproduction strategies over millions of years. Recent research demonstrates that testicular size compared to other body parts likely changes more rapidly due to evolutionary pressures. Therefore, in the future, human testicles might shrink or grow based on selective pressures. Your testicles aren't just reproductive organs, they're biological archives recording evolutionary trade-offs between attracting mates and producing competitive sperm. Whether yours are larger or smaller, positioned higher or lower, they reflect millions of years of primate evolution, optimizing reproductive success through different strategies. Understanding this science connects you to the broader story of human evolution and the fascinating biological diversity within our species. If this changed how you think about human biology and evolution, hit that subscribe button. Drop a comment sharing which fact surprised you most. Thanks for watching. See you in the next one.